Welcome back. In the last session, we started RC phase shift oscillator and we derived the beta transfer function, and it depends on J term. Therefore, now we need to put a condition such that your beta network will be independent of J. If it is independent of J, then either you get 0 degrees phase shift or 180 degrees phase shift. We don't want other than 0 and 180, because if you get other than 0, 180, it's difficult to get non-zero, non-180 degrees phase shift from open loop amplifier. Therefore, we want to make, or we want to have a frequency, resonant frequency at which your beta network will give you 0 degrees or 180 degrees. For that, it should not have any J term. Okay, that condition I'll explain. Right, that is what is satisfying or following Bar-Cousins criteria. Before that, I asked you one question where, if you know RC network transfer function, if all are in cascade, we cannot multiply in this scenario. That is what I told. What is the reason? Therefore, whatever control systems techniques we studied, are they not valid? Here I am saying not valid, means they are not valid. They are valid provided something. What is that something? Remember why it is not valid? I will explain with an example. Then shall we complete this and then come back to this, why we should not take it? Okay, that part I will explain. Let me complete this first, then I'll come back, then I'll explain why this is not valid. Okay, fine. Can I erase? We know beta, right? Now let me replace beta network with this, then let's see. Okay. Now, therefore, can I replace the circuit like this? Now, this is what your amplifier. This is your amplifier A. Now, this is what is your RC network. This output is taken and given to your open loop amplifier. Therefore, this is C, R. Therefore, this is what is your beta network. Okay, this is what your beta network. Now, beta network is replaced by 3 RC networks, right? And we know what is beta. Therefore, beta is equal to 1 minus 5 alpha square minus j into 6 alpha minus alpha cube, right? Where alpha is equal to 1 by omega RC, right? Now, the first point, to get F naught, to get frequency of oscillations, which is nothing but resonant frequency F naught. Okay, now listen. Now, the frequency at which beta network is giving 0 degrees or 180 degrees, and obviously this is 0 degrees or 180 degrees, to get total loop phase shift 0 degrees, that will be your frequency of oscillations, right? Now, I want to make beta independent of J, right? Therefore, to get angle of beta 0 degrees or 180 degrees, anything, we don't know, 0 degrees or 180 degrees. Therefore, beta network should be independent of J, should be independent of J term, independent of J term, right? Therefore, to get this, now what is the condition? Therefore, the condition is, what is the condition? 6 alpha minus alpha cube should be 0. If 6 alpha minus alpha cube is equal to 0, the J term is not there. Therefore, your beta network will be independent of J. That is what we need. Therefore, condition is 6 alpha minus alpha cube is equal to 0. For what frequency 6 alpha minus alpha cube is equal to 0, that will be your resonant frequency. Let's see. Therefore, what is this? This is nothing but 6 alpha is equal to alpha cube. Then cube square will be cancelled. Therefore, alpha square is equal to 6. Then alpha is equal to root 6. Therefore, what is alpha? Alpha is equal to 1 by omega RC. Therefore, 1 by omega naught RC or omega RC is equal to root 6. If you write, which is nothing but 1 by 2 pi, this is nothing but resonant frequency F naught into RC is equal to root 6. Therefore, what is your F naught? Your F naught is equal to 1 by 2 pi R into C into root 6. This is what is your resonant frequency from RC phase shift oscillator, provided other things are also satisfied. Let's see, to make other things satisfied and then say that this is what is F naught, which is resonant frequency. Okay, tell me at F is equal to F naught. Therefore, at F is equal to F naught, definitely it will be either 0 degrees or 180 degrees. Let's see, that is what we want to find. At F is equal to F naught. Tell me what is your beta network? Then beta is equal to what? Then beta is equal to, right? At F is equal to F naught means what? At this frequency, your 6 alpha minus alpha cube is equal to 0. This is 0. And what is alpha square? Alpha square is equal to 6, right? Maybe you can say this is what is equation 1. And this is what is your beta network. Therefore, this is what is star. Make it a star. Therefore, star implies what is beta? Beta is equal to 1 minus 5 into what is alpha square? That is 6. That is from 1. Therefore, from equation 1. From equation 1. And this is 0. 6 alpha minus alpha cube is equal to 0. Therefore, tell me what is beta? Beta is equal to minus 1 by 29. Therefore, what does it mean? What does it mean? This is what is having. Therefore, beta is nothing but minus 1 by 29. Therefore, what does it mean? Magnitude of beta or angle of beta, that is primary, not magnitude. Okay. Therefore, what is angle of beta? Angle of beta, because of minus, angle of beta is 180 degrees. Therefore, your beta network is giving 180 degrees phase shift at F is equal to F naught, means that F naught is equal to 1 by 2 pi RC root 6. Therefore, at that frequency, your beta network is giving 180 degrees phase shift. And what is the gain of the beta network? That is nothing but mod beta, which is equal to 1 by 29. Therefore, according to Barkhausen criteria, first point is satisfied, right? What is that first point? At frequency, right? At what frequency the closed loop phase shift is 0 degrees. Now we know that beta network is giving 180 degrees. This is what is giving 180 degrees. When this is what is giving 180 degrees, now it has to give 180 degrees phase shift. If this is giving 180 degrees phase shift, then what is total loop phase shift? But this is what is giving 180 degrees phase shift at what? At resonant frequency F naught. That is nothing but 1 by 2 pi RC root 6. Therefore, at resonant frequency, it is giving 180 degrees phase shift. At that frequency, if this is giving 180 degrees phase shift, you will get oscillations. You will get oscillations. Therefore, to get total loop phase shift, to get a total loop phase shift is equal to 0 degrees. To get total loop phase shift is equal to 0 degrees. Your angle of A should be 180 degrees. Angle of A should be 180 degrees. This is also requirement. That is due to beta network. Therefore, your beta network is giving 180 degrees, but to get total loop phase shift is equal to 0 degrees, your angle of A should be 180. Therefore, it has to give 180, 180, 180, 0 degrees. Point number 1 satisfied. Now point number 2. Point number 2. Point number 2, to get sustained oscillations. Yes, we are getting oscillations. This is giving 180, this is giving 180 at F0. Therefore, that is resonant frequency. You are getting oscillations. But what is second point? Once you get oscillations, yes, it is in regenerative feedback or positive feedback. Once we are getting oscillations, what do we need? We want sustained oscillations. We don't want over-damped oscillations. We don't want under-damped oscillations. We want sustained oscillations. Therefore, tell me, to get sustained oscillations, to get sustained oscillations, to get sustained oscillations, total loop gain, which is magnitude, right? Total loop gain must be equal to unity. What is that? Mod A into mod A beta should be equal to 1. And what should be mod A? Mod A should be equal to 1 by mod beta. What is mod beta? 1 by 29. Therefore, what should be mod A? Mod A should be equal to 29. Therefore, overall, if you ask me what should be your gain, therefore this is what your mod A should be equal to 29. Therefore, what is summary? If you ask me summary is nothing but at F is equal to F0, your beta is nothing but minus 1 by 29. Therefore, your A should be equal to minus 29. Beta is equal to minus 1 by 29 and your A is equal to minus 29. Therefore, what is this? This is what is giving mod angle of beta. Angle of beta is equal to 180 degrees and angle of A is also 180 degrees. But the magnitude of A is nothing but 29. Remember, there is a loss of beta network. What is the loss at phase shift 180 degrees or at resonant frequency? 1 by 29. Therefore, it is having a loss of 1 by 29. It is a loss factor of 1 by 29. There should be a gain factor of 29 by open loop amplifier. That is what is your RC phase shift oscillator. Hope everyone understood, right? Here I am explaining with respect to phase response separately, magnitude separately. But if you combine both of them, minus is indicating 180 degrees. 1 by 29 is nothing but your mod. Therefore, it has both phase shift as well as magnitude. Okay, take it. Where F0 is nothing but 1 by 2 pi RC root 6. That is the summary. Where F0 is equal to 1 by 2 pi RC root 6. Hope everybody understood. Therefore, out of these two, which is controlled, or I can say which is what is giving you resonant frequency? Beta network is giving resonant frequency. At that frequency, it should give 180 degrees. At that frequency, the gain of your open loop amplifier should be 29. If your amplifier is not able to give gain of 29 at that frequency, remember, you will get under damped oscillations. Those oscillations will die. You will not get oscillations. Okay, your open loop amplifier should give 180 degrees phase shift. Not only that, it has to give gain of 29. Okay. If you take A into beta, therefore A into beta is equal to 1. What does it mean? Loop gain is 1, loop phase shift is 0 degrees. That is what it is. Okay. Thirty more seconds. After that, I'll explain the figure of merit. And before that, before explaining figure of merit, I should explain why we are not taking like control systems transfer function. I told you, right, G1 of S into G2 of S into G3 of S. Why are we not considering that here? Okay, that I'll explain. Then I'll explain the figure of merit of RC phase shift oscillator. If this is what is your final amplifier, why are we, sorry, final oscillator, why are we going for next type of oscillators, right? That part I'll explain later. Using Opamp, can you get gain of minus 29? Yes, inverting amplifier. What is gain of inverting amplifier? Minus R2 by R1. Take R2 29k, R1 1k. You'll get minus 29. Straightforward. That is easy. Hope this is done. Okay. Can you erase this? Therefore, how to get gain? Therefore, what is your open loop amplifier? Now, open loop amplifier A, open loop amplifier, right? You can take open loop amplifier A. Therefore, you can take your Opamp as open loop amplifier, which is what is going to provide. This is R2 and this is R1, right? Now, this is what your open loop amplifier, but output should be given. Therefore, it has to have RC, RC. This output should be given to your amplifier input. Okay, now this is what is C. This is your practical RC phase shift oscillator using Opamp. Okay, now if you ask me, this is what is the output. If you compare with respect to the block diagram, this is what your beta network, output of beta network is given to your, when I say open loop amplifier, with respect to A beta, this is open loop amplifier, but this open loop amplifier is implemented using Opamp. Therefore, this is what your open loop amplifier having a gain of minus R2 by R1. Therefore, now if you ask me, this is nothing but your open loop amplifier. This is your open loop amplifier, right? And this is what is your beta network. This is what is, therefore this is beta network, and this is what is your open loop amplifier A. right? Output of beta network is given to input of your open loop amplifier, output of open loop amplifier is given to input of beta network. This is what is completely your RC phase shift oscillator. Therefore, what is A? Therefore, A is equal to what? Minus R2 by R1. Therefore, if you choose, right? If we choose R2 is equal to 29K and R1 is equal to 1 kilo ohm. Therefore, then what is the open loop amplifier gain is equal to minus 29. Therefore, when you get minus 29 and beta network that is giving minus 1 by 29, then overall A beta is equal to 1. Therefore, you are going to get oscillations. Okay. If you are not getting A minus 29, remember, or mod A 29 or mod A if it is less than 29, then overall loop gain will be less than 1. A beta mod A beta less than 1, you will get even the total loop phase shift is 0 degrees at resonant frequency. If mod A beta is less than 1, you will get under damped oscillations. Even oscillations will be died out. Okay, because whatever loss we have from the beta network, same amount of energy should be boosted or gained by your open loop amplifier. If the loss is not equal to the gain, let us say the gain is less than the loss, after some time the oscillations will be died out slowly. Okay, that is what it is. Okay, take it. This is what is your final circuit. Maybe if you want to get RC phase shift oscillator, take Opamp, R1, R2, 3 resistors, 3 capacitors, connect it, right? Then you get F0 is equal to 1 by 2 pi RC root 6. Therefore, your resonant frequency is dictated by, remember, beta network, not open loop amplifier. But your open loop amplifier gain is the one which is what is giving you sustained oscillations. But the resonant frequency is dictated by your beta network. Therefore, F0 is equal to 1 by 2 pi RC root 6. Let us say you want 1 kHz. If you want 1 kHz, you 1 by 2 pi RC root 6 is equal to 1 kHz. Then take some R value, then find C. You try to put that C here, then you will get resonant frequency to that. Okay, that's fine. Now, let me explain the doubt. Let me explain the question what I asked related to the beta network transfer function calculation. Okay. Okay. Before going that, can I erase this? Done? Okay. Now, let me ask you, then I'll come back to this. Okay. Example. There is a network. Okay. There is a network, but you don't know what is there inside. Let us say it's kind of black box. Let us say this is 10 volt battery and this is 1 ohm. Tell me what is your terminal voltage? Your terminal voltage is nothing but what? Your terminal voltage is nothing but open circuit voltage. Then you take voltmeter, you bring voltmeter and you connect voltmeter here, your voltmeter will not load your circuit. It just measures whatever voltage you have across open terminals. It just measures and then give you. Tell me what is open terminal voltage? Your open terminal voltage is nothing but 10 volts. Therefore, it will measure. It will give you 10 volts. Therefore, it measures open terminal voltage. Open terminal voltage. Open terminal voltage. Therefore, what is that? That is what is equal to 10 volts. Then based on this, what you say? You will say that it is 10 volt battery, right? Just let's say I told that it is a battery. Then I'm asking you what is the voltage of that battery? Then what do you do? You will take voltmeter, put voltmeter across that open terminal. Then you will say that you are seeing 10 volts. Therefore, you will say that it is 10 volt battery. But this is example 1, or I can say this is example. Now here open terminal voltage, if load is connected, if real load is connected, then this is what is your battery, right? And this is what is your internal circuit. This is 10 volt battery but having 1 ohm. Then when you connect real voltage or real load, let us say a bulb is connected or whatever it may be, some real load is connected. Let us say the real load is nothing but what? 10 ohm. Just assuming. Now I am asking what is the voltage? What are you expecting? Whether load is connected or not connected, we are expecting 10 volts. But remember, if you don't have any load, using voltmeter, we got 10 volts. But when the real load is connected, now what is the voltage? Is your voltage 10 volt? Whatever you had seen from voltmeter, are you going to see the same voltage? No. That is because of loading effect, because of practical voltage source. Therefore, what is that V? That voltage V will be equal to 10 divided by R2 divided by R1 plus R2 into 10. Therefore, 10 divided by 11 into 10. What is this? You will get around 100 by 11, which is nothing but 9 point something. Therefore, you will get close to 9 volt. Therefore, we are expecting 10 volts, but we are getting in realistic scenario 9 volts. That depends on, again, the voltage what you are going to get across the load is depending on the load what you have. Let us say my load is 1 ohm. If my load is 1 ohm, you will get 5 volt. If my load is 100 ohm, you will be getting close to 10. If my load is 0.5 ohm, your voltage will be less than 5. Therefore, the voltage what you are applying across the load is depending upon the load. This is what is having loading effect. This is due to loading effect. Due to loading effect. Your load is affecting your output voltage. Therefore, this is what is due to loading effect. Therefore, because of loading effect, when I say this is what is my input voltage, but my output voltage, therefore the relation between input and output is changing because of loading effect, right? That is because of practical voltage sources. Similarly, this is one of the example, right? Now, similarly, if you take beta network, if you take simple RC network, this is what is our RC network. This is what is our RC network. Okay. Same example. Let us say this is R, this is C. Now we are trying to find, let us say this is your VI, this is your VI, and when you say this is what your V naught, right? And if you treat that, if you treat, this is what is our black box. Now you are trying to get what is V naught with respect to VI. That is nothing but what? That is nothing but, therefore what is V naught by VI? That is our transfer function, right? What is the transfer function? Which is nothing but H of S. Therefore, in this case, what is H of S? H of S is equal to 1 by SCR divided by 1 plus SCR. It is open terminal, but the same thing is expected at any case, right? Therefore, when I say this is what, if load is connected, for this, if load is connected, this is what is without any, and this is what is measures. Excuse me. Therefore, here this is what is open terminal voltage. Open terminal voltage. Don't say that R is there. How can you say open terminal? Here it is open terminal. If load is connecting the real load, because you are going to take this output and then give it to some other circuitry, right? That circuit input impedance will be coming as load. That load will affect your transfer function. That is not accounted in control systems. Okay, this is what is open terminal voltage without load, but now if load is connected, right, if real load is connected, if this is what is case A, now this is case B, similarly this is what is case A, now this is case B. If real load is connected, then what does it mean? This is what your capacitor and this is resistor, okay, and this is what your output. Now real load is connected and this is what is your VI, right? Then this is what is your black box. We are expecting same V0, but the real load, let us say it is some load is connected. Then what is your V0? Then whatever V0 you get, this is what your V0. Then tell me what is your V0 now? Your V0 is not simply SCR divided by 1 plus SCR into VI, because this load will be coming in parallel to R. Therefore now your effective resistance divided by that effective resistance divided by 1 plus SC. Therefore you will get new transfer function. You will get H dash of S, which is new, which is V0 by VI. Therefore this is new transfer function due to loading effect, Therefore whatever, that's what I am saying. Let us say this is what you are having, some transfer function which is SCR by 1 plus SCR. That output, therefore this is also, we cannot multiply like that, because whenever you have, when load is connected, that input impedance is coming in parallel to your R. Therefore the transfer function of your RC network will change, will be altered. If that is what is changing, then the transfer function, we cannot take SCR by 1 plus SCR for all and then multiply. We cannot do it. But remember, in the case of control systems, right, when you say G1 of S, G2 of S, the assumption is there is no loading effect. That is the assumption. Then what does it mean? It has finally the buffer, which is what is isolating source and load. That is the assumption. With that assumption, we can take G1 of S into G2 of S. Remember, I am going to use this technique to solve one of the problems. Amplifier 1, amplifier 2. Amplifier 1 is having a gain, right? Amplifier 2 is having a gain, but when you combine, you will not get A1 into A2 because of loading effect. The input impedance of second stage will be the load for your first stage. That load now, whatever load it has internal, and then input impedance of the second stage will come in parallel, then the first stage gain will be affected. That is what is due to loading effect. We are going to solve that problem. Therefore, A1 into A2 is not straightforward. A1 into A2 you can take, or G1 of S into G2 of S you can take, provided there is no loading effect. Therefore, we should insert buffer amplifiers in between. If it is a voltage amplifier, voltage buffer amplifier. If it is a current amplifier, current buffer amplifier. That is what we need to insert. Therefore, loading effect can be avoided. Then we can directly multiply G1 of S into G2 of S. I hope this is clear. I explained using network analysis. Okay. That is the reason why we cannot multiply directly, because the input impedance of the second two RC networks is the parallel impedance to your R. Therefore, your transfer function from the first RC network will be changed. We cannot use that as it is. If there is no load, yes, you can use it. If there is a load, we have to calculate including that load and then calculate the transfer function. Therefore, your transfer function will be changed. Okay, take it. That is the reason why I didn't go for just simply transfer function multiplication. I just applied considering the load, the nodal analysis V1, V2, and then voltages. Then apply nodal analysis. If you consider all the loads, real current flows, then we will get really what is V0 by Vi. Okay, take it. And one more point I want to explain, because we considered op-amp here, it has some output impedance. What is output impedance in the order of 10 ohm? Let us say output impedance is in the order of 10 ohm, because the resistors will be in the order of kilo ohm, you can neglect the output impedance of your op-amp. This is very important point, because I am going to use that point later on in the case of some amplifier, but I don't want to name, I will name after that. Therefore, I am going to consider the op-amp output impedance also. Even though that is 10 ohm, the 10 ohm is significant due to the beta network change. I am going to change the beta network. As beta network is changing, because this is in the order of 1 kilo ohm, I can neglect op-amp output impedance. But if it is in the order of 1 ohm and all, or 2 ohm or 3 ohm, then op-amp output impedance 10 ohm or 5 ohm is also significant. Then in that case, we need to consider that also. In the case of RC phase shift oscillator, I am not considering op-amp output impedance. Okay, take it. See, these are all observations. You'll get it from practical analysis. Thirty more seconds, then I'll explain the figure of merit of RC phase shift oscillator. Means limitations and then advantage. Actually, limitations only I'm going to speak. Then only that will motivate you to go for next circuit. Done? Okay. Now let's see the figure of merit. Actually, there are 2 points which we consider as figure of merit. Then using those 2 points, we say whether it is good oscillator or not. Then we can compare those 2 points for every oscillator. Then we can say which is better when you are comparing with the 2 oscillators. Okay. Now, figure of merit. Number one, frequency range. Okay. Now, if you ask me, right, therefore frequency range of RC phase shift oscillator. Frequency range of RC phase shift oscillator. Remember, I am speaking with respect to olden technology, like let us say 1980s circuits. Okay, with respect to 1980s or 1990s, you can say, right? With respect to that, I'm just comparing. Okay, therefore frequency range of RC phase shift oscillator, that is in the order of 100 kHz. What does it mean? What does it mean if you want to get, let us say 0 to or low frequency to 100 kHz? If you want to get the frequency of oscillation, right, which is equal to 1 megahertz, let us say. Therefore, example, I'm just taking example, right? I want to get F naught, to get F naught is equal to, let us say, 10 megahertz. I'm just taking example with respect to RC phase shift oscillator. Then normally what we do, right? Maybe what I say, to get F naught is equal to 10 kilohertz. This is example 1. Okay, to get our example 1. This is what is example 1. To get F naught is equal to 10 kilohertz. Right? What you do? To get F naught is equal to 1 kilohertz, then consider F naught. We know that F naught is equal to 1 by 2 pi RC into root 6. Then what we do? Substitute F naught is equal to 10 kilohertz. Right? Then take, let R is equal to 1 kilo ohm. Right? Then find C. Substitute that C, right, in the RC phase shift oscillator circuit, then you will get oscillations. Therefore, if you see observation, we will get oscillations with F naught is equal to 10 kilohertz. That is fine. Therefore, you will get it. Now, example 2. Now, to get F naught is equal to, let us say, 100 megahertz. To get F naught is equal to 100 megahertz. Now, what we do? Again, same technique. We know that F naught is equal to 1 by 2 pi RC root 6. Right? Substitute, which is nothing but 100 megahertz. Right? Now again, let R is equal to 1 kilo ohm, then find C. But observation, after keeping R, C, F naught, if you see observation, right, we will not get oscillations with F naught is equal to 100 megahertz. We will not get oscillations. Why? That is what is the meaning of range. Means if you want to get higher frequency of oscillations, right, in the order of megahertz and all, we cannot get using RC phase shift oscillator. I'm just taking as a reference olden technologies. Therefore, what is the reason? The reason for it is what? The reason for it is, for example, I want to get oscillations at 100 megahertz. If I want to get oscillations at 100 megahertz, yes, what is your requirement? At 100 megahertz, it should give 180 degrees phase shift. Yes, we will get 180 degrees phase shift. To get 180 degrees phase shift, I am choosing C, R, therefore I am getting 180 degrees phase shift. That we can get it. And I need 180 degrees phase shift. Yes, I will get 180 degrees phase shift. But I want gain to be equal to 29. But remember, your open loop amplifier is limited with bandwidth. Your open loop amplifier is limited with bandwidth. Why? If you ask me why, the reason is your open loop amplifier is having a bandwidth. Let us say I am taking open loop amplifier gain, then it is what is having, let us say this is what is having a gain of 29. I agree. But let us say this is what is having, the 29 is almost flat, or whatever you want, let us say up to, let us say 100 kilohertz. Then after 100 kilohertz, your gain mod A is less than 29. That is what is the limitation from your open loop amplifier. Your open loop amplifier cannot give gain 29. That is what is my requirement to get sustained oscillations. I will not get gain 29 above 100 kilohertz. Let us say this is what is having a bandwidth, right? Means where the gain is to, I am just taking Bode plot. Therefore, my bandwidth is 100 kilohertz from your open loop amplifier. Now I want to get oscillations 100 megahertz. I cannot get it. Because your mod A beta, your total loop phase shift is 0 degrees, that is satisfied. You are getting oscillations of F naught, but that F naught frequency of oscillations will be died out because your mod A beta will be less than 1. Because your beta is always 1 by 29 at F naught. Therefore, your mod A beta will be less than 1. Then we will see under-damped oscillations. Okay. Now, This is what is the limitation. Therefore, everybody understood the frequency range of RC phase shift oscillator is 100 kHz. Okay, that is one thing. And second thing is there is no frequency stability. No frequency stability. What do you mean by frequency stability? Okay, let us say that part I will explain. Therefore, what does it mean? Okay, I'll explain. Therefore, let us say let F naught is equal to, which is nothing but 1 by 2 pi RC root 6 is equal to some 1 kHz. I am expecting 1 kHz, but if temperature changes, if temperature increases, if F naught changes, therefore there is a change in F naught, therefore F naught is not constant, F naught is not stable, there is no stability. I'll explain a little bit about this, but the observation point, figure of merit is nothing but two things, the frequency range of oscillator and the frequency stability of an oscillator. Okay, you take it, but I'll explain a little bit, but I'm saying that is because of R. If temperature is increasing, let us say R is changing. If R is changing, then F naught will be changing. Therefore, F naught is not constant. I'm expecting 1 kHz, but if temperature changes, it is not 1 kHz, it will be 1.05 kHz. There will be a variation in the frequency due to temperature or any other effect. Therefore, there is no frequency stability. That is the limitation. Okay. You take it, then after that I will start and I'll explain a little bit about this in the next session, not now. Then we will continue to next oscillator. See, RC phase shift oscillator took more time because I told you the initial analysis always will take time. Then later on the same things will be observed. Then we can go faster. Okay. Write down. We have 1 minute time for this session. Therefore, within 1 minute you try to complete. Else, you can pause the video and then you can write down. Then we will continue in the next session. Okay. Please continue. Okay. Thank you.